An inductance loop detector is a predominant traffic sensor type deployed to measure speed and vehicle length. However, approximately 80% of inductance loops in Washington State are not working properly. The sensitivity problem has been identified as the main source of inaccurate loop measurements. The sensitivity problem can be divided into two categories. First, inconsistent sensitivity between the upstream and downstream loops, which results in inaccurate speed and vehicle length measurements. Without this problem, the speed measurement will be accurate. And secondly, consistent but unsuitable sensitivity levels on both single loops. This problem can lead to too long or too short vehicle length measurements. If both single loops are too sensitive, vehicle length will be overestimated. In contrast, if the two single loops are not sensitive enough, we will have an underestimated vehicle length. The Advanced Loop Event Data Analyzer, or ALIDA system, was designed to identify and correct a dual loop sensitivity problem. The system can record cabinet information, classify vehicles, display loop status, adjust spacing distance between upstream and downstream loops, and also display the sensitivity of those loops. To begin, specify a place for the event data and for the traffic data to be saved. Then press Start. ALIDA calculates the vehicle on-time differences between the upstream and downstream loops and uses them to represent the sensitivity and consistency. The on-time of both single loops should be the same if sensitivity of both loops is at the same level. By adjusting the loop amplifiers until the on-time differences displayed by ALIDA become close to zero, the dual loop inconsistent sensitivity problem should be minimized. As mentioned earlier, even though the sensitivity levels of both single loops are in agreement, both loops can be over or under sensitive at the same time, which results in inaccurate vehicle length measurements. To identify this problem, we applied the ground truth short vehicle length distribution. Since the standard deviation of short vehicle length is small, approximately 2.2 feet, it is reasonable to assume that the observed short vehicle length distribution should be very similar to the ground truth distribution if the dual loop sensitivity level is suitable. Therefore, ALIDA can identify the sensitivity by showing the comparisons between the observed and ground truth vehicle length distributions. If both distributions are similar, a dual loop should not have a sensitivity problem. Alternatively, the sensitivity levels of both loops must be equally adjusted in the same direction until the observed length distribution is close enough to the ground truth.